Nelson Mandela once said, "Education is the most powerful weapon you can use to change the world." Hi everyone, welcome back to yet another mathematics video with my dad, Mr. Albert Stevens.
Alright guys, welcome back to yet another video. We're going to look at sets. Alright, so let's begin. We'll look at Venn diagrams. Alright, so let's look at this question here. So we have two sets, A and B. A is 4, 7, and 9. B is 1, 2, 3, 4, and 5. Alright, so we want to represent this information, these two sets on a Venn diagram. So as you can see, between sets A and B, 4 is common. Alright, so we're going to use, by the way, the rectangle represents the Venn diagram and circles represent the sets. So we're going to have our two circles, and inside the two circles, as you can see, we're going to have 4. Alright. So as you can also see that in set A, 7 and 9 are in set A, but they are basically all by themselves. So we call it A alone or A only. Only 4 would share set B. So 7 and 9 will go there. Likewise in B, in this section here, we would have 1, 2, 3, and 5. Also, 0, 6, and 8 are neither in A or B, so we put them outside the circle. Alright, so that's that. Alright, let's look at some key definitions. So we have intersection of two sets. Now, intersection of two sets is simple, just mean what is common between A and B. And this is a symbol that we use. It's like an N, but it's not really an N. And this is a region, a shade region, that represents A intersect. So that's A intersect B. We also have union. Now the union is basically everything. So A union B means either in A or B. Complementary of a set. Now A complement means what is not in that set. So for example, we have this set here, A. So A complement would be outside. Alright, and we use a little stroke at the top to represent A complement. So A complement means members that are not in the set. And the universal set is basically where we take all the elements from, and that is represented by a rectangle. So we have another one, a subset. So a subset is when you have all the members of one set contained in the other set. All right, so if you look at this circle here, everything in A is contained in B. So we say A is a subset of B, and this is a symbol. All right, so this is another notation. So this represents the number of elements in a set. So for example, if you have a set, right? For example, you have set A, and A having A, B, and C. Set A has 3 elements. So this means that the number of elements in set A will be equal to 3. We have the empty set, which is represented by a 0 and a cross. Alright, and there are no elements in the empty set. Alright, so we will look at something called set builder notation. And basically, these are some symbols that we use. Well, we have been using them a while ago, like A intersect B, A union B. Those symbols, they call it set builder notation. So for these series of diagrams, we will explain to you what the regions mean. All right. So as you can see, this is A union B complement. All right. And we will show you. We will shade in the region that represents A union B complement. All right. So here we go. So A union B complement is this area here. Let me highlight it. So it's everything, all of that region here. So all of those regions, all of that region is A union B complement. So what do you notice? The only thing that's not shaded is actually B. Let's look at another one. So this is A complement intersect B complement. So let us see which area is going to be represented by the set builder notation. As you can see, it's everywhere outside the circle. So right along here, all those regions. So don't touch the circle at all. So A complement intersect B complement is represented by everything that's outside the circle. One way you could look at it, you could say, okay, this means what is not in A and not in B. What's not in A and not in B is actually outside A and B. Alright, so this one now is A intersect B complement. Alright guys, so look at this question. Oh, let me just go back. Look at this question. This is A intersect B complement. But previously, share something. Where is it? I'm gonna go back. All right. So notice that this was A union B complement. A union B complement is everything except B. And when I say everything, it means on the outside too. So let's fast forward to this. All right. So this is not union now. This is what? Intersection. All right. Now this is different from the previous one I'm going to show you a while ago. A intersect B complement actually means what is in A but not in B, or A alone. All right. As you can see, it's this area. So A intersect B complement is represented by this shaded region here. As you can see, it don't touch B none time at all. But also to know that it didn't go outside the circle. All right. All right. Now this is A union B complement. Now if A union B means the entire two circle, so A union B means the entire circle, both of them. So A union B complement would be everything outside the circle. All right. What about this one? A complement union B complement. What do you think that is? Let us see. All right. So it's everything except this little part here. All right. So A complement union B complement is everything except the intersection here. Right. So we're moving on, and those were set builder notations. Let's look at let's see if we can test your skills. So basically, the diagrams will be shaded, and you'll be asked to write the set builder notation. So what do you think this one is? Well, it's B intersect A complement. What is in B but not in A? Right, so moving on to the other one. What do you think that one is? Right, so it's A complement union B. All right, so remember, complement means not A. Moving on to the other one. So this one is A union B complement, which we did a while ago. All right, wow, look at this one now. This one we have 3 sets. And what is shaded is everything outside those 3 sets. So obviously it will be A union B union C complement. All right. Let's look at some practical example. All right. So the universal set here is our natural numbers that are less than 16. And the question says describe set A and set B. So look at the numbers for set A and tell me what you think. Well, it turns out that set A are just even numbers. That's less than 16. All right. And notice the word less than 16. So less than 16 means that, well, it cannot go up to 16. So the highest number there would have been 14. All right. What about set B? Look at all the numbers in set B. What type of numbers do you think those are? Well, you've got it right. Those are prime numbers. And just to mention, 2 is the only even number that's a prime number. All right, and you notice we have 1, 9, and 5. All right, So 1, 9, and 5 are neither even nor prime. Alright? Okay. Next question. Describe the universal set A, set B, and set C. So have a look at those. Look at the elements in set A. What do you think? Well, the universal set is just a set of numbers, counting numbers starting at 10 and ending at 30. But set A turns out to be, again, even numbers. What about set B? Set B are multiples of 3. What about set C? Set C are multiples of 5. Continue. So guys, that's a little introduction to set theory, basic concept. I hope you find this video informative, and I'll see you again. Thanks for watching. Please remember to keep safe